Uh, Assalamu alaikum wa rahmatullahi wa barakatuh. A very good morning to all of you. Now, uh, first of all, I want to welcome you to this wonderful platform where we are going to be sharing many things here and there. Secondly, I want to refer you to the attachment that is put on this video. Then you get the notes from there. The other thing is the WhatsApp platform that we have, the WhatsApp group for Form 3s. You can also go there. The notes have been put there by Pfizer. I think Pfizer has put there the notes. Yeah, those are the questions that we are going to do for this in this session. Now, I request that we get those questions here and there. Today, as I told you, those of you who have been in the WhatsApp groups that we are having, I mean the WhatsApp group, if you want to join the WhatsApp group and you're not there, please contact Shadia Senior 3A. She will automatically add you to that group. Or else, you WhatsApp me on 0786019648. I personally will add you in the group. So, today, as I had clearly indicated, that we are going to look at the algebraic fractions and equations. We have a problem in math that very many people having the concept of math. You can teach them different topics, but problems may come in if a person is green about the algebra or what you're supposed to do when you meet algebraic fractions and equations. So in this session, I'm going to take us through the algebraic fractions and equations. And by the end of this lesson, trust me, I'll give you the tasks that you're going to do, and you will give me the feedback using the WhatsApp platform, because we can't spend the whole day here. So that is the introduction that I had to give you, and I request that we get into the business. Now, when I talk of the algebraic fractions, you can deal with them by ordinary cancelling. As you know, we cancel numbers. So the algebraic equations can also be done like that. Always make sure that what you're cancelling is a genuine factor of, if it is a numerator, you're cancelling the denominator, you must know that it is a genuine factor of the numerator. If you're cancelling the denominator, let's say if I have a fraction, let's say A over B. Now this one in a fraction, it is termed as the numerator, and this one is termed as the denominator. I think you've all looked at this in senior 1. Now, in algebraic fractions, we are going to be looking more of the numerator and denominator, and cancelling is going to be very common. Now, the questions, as I told you, please, you can first check into the attachment or go to that WhatsApp group, get that PDF for the questions that we are going to look at. But we are looking at algebraic fractions and equations for today in this wonderful session. Secondly, if you have any question that you would want to give me, please, you can go to the comment section, write there your question, and I will ably reply you, because people are going to give me the questions here that you're sharing. I will ably reply you. Please don't hesitate to write a comment or a question if you have any. I will ably reply you. Now, straight away, we are going to go at the examples, because in math, we basically look at examples, and we do the examples. And with the examples, I'm going to do some examples, and I will refer you to other examples also. Now, let me write down the examples, as I told you the meaning of example 1. And they are telling us to simplify the following fractions completely. Simplify. Now, in the first place, we are going to look at the algebraic fractions. Basically, we are going to first concentrate on the fractions, basically. Now, we simplify the following fractions completely. Completely. Simplify the following fractions completely. Now, if you're told to simplify the fractions, what do? What are the fractions? Part A. Part A. Part A. We are simplifying x squared minus y squared over what? Over x squared minus xy. Okay? That is the example one that we are going to deal with. When you look at this example here, it is a fraction. Now, the upper part of this fraction, we call it a numerator, and the downer part, we call it a denominator. But right now, after looking at what we had in the first place, allow me to split this. And I think all the streams, in our respective streams, we looked at a topic known as quadratic equations, expressions, and so on and so forth. Now, in that topic, we had to look at the difference of two squares. When you look at the upper bit of it, remember we said for the difference of two squares that if you have a squared minus b squared, it will eventually give you a plus b, a minus b. This is what we call the difference of two squares. Don't you tell me that you also have the addition of two squares. No, it is called the difference of two squares. And most people basically confuse a minus b squared to be a squared minus b squared, which is wrong. It cannot happen. When you have this, what does it mean? It means that if you have a minus b squared, it will be a minus b, again a minus b. It means that you're going to multiply these two times. As you can see that if you have 2 squared, it is the same as 2 times 2. But if you have this one is 2 times 2. So if I have a minus b squared, it is the same as a minus b, and this one will give us, I multiply this one with the whole of this, a minus b into a minus b, as you can see there. Then eventually when I open the brackets, this will be a squared minus ab. This time with this, it is minus ab, and eventually this will be plus b squared, because you multiply a negative times a negative, it will yield a positive sign. Then this will be a squared minus 2ab. Why is it 2? Because there is a silent 1 and a silent 1 here. So when you add them, you get negative 2ab plus b squared. This is what is going to come out of a minus b squared. But if you have, let's say you have a squared minus b squared, it cannot give us this. For it, it will give us a plus b, a minus b. And even if you multiply these, it will go back to this. That's what I was trying to clarify. I was trying to give clarification on these things here. Now, when I continue here, I've been talking about the difference of two squares. Remember, I hadn't started on the question that we have before us. But now when you look at this one will equal to, as you look at the difference of two squares, x squared minus y squared will yield x plus y, x minus y, as we say the difference of two squares, over, and then when you look at this one, what is common? Automatically you can see that x is common on both the terms. So I'm going to factorize out x, and then I remain with, when I factorize out x, this one will be x minus y. You can see that, because here there have been two x's. When I remove one, I remain with one, and here there is one x when I remove it, so that when I multiply this again, I go back to this. Now you look at these fractions, and you see the brackets which are common. Now the brackets which are common are the ones that we are going to cancel out, and eventually this is going to be x plus y, x minus y, over x into x minus y. Then we cancel down the brackets. This one will go with that, and finally we remain with x plus y over this bracket. Now I don't need to put a bracket again because it is just one term, the whole of it, over x here remaining with only x. Now some of you have a tendency of crossing this with this, but that is a suicide mission. You'll have killed yourself by hanging yourself over, I don't know. But this one can never cancel with this if there is an addition sign in between them. They can only cancel if there is a multiplication sign in between. But if there is addition or subtraction, This one and this one cannot cancel. So eventually, this is our answer. Or that is the solution. You cannot simplify this any further. So this is the easiest simplification that you can give to this expression here. That is part A. We are simplifying the following fractions completely. That is part A. For those of you who have those questions that we are doing here, you're on a safe side. And those of you who don't have, please write down my WhatsApp number after this lesson. You'll have to tap on me. It is 0786. I'm repeating for those of you who are just coming. 0786019648. You tap on me, or with any question you can always ask me. And if I give you the exercise, please you do the exercise and give me the solutions on the WhatsApp. I will have to mark you there. Okay. Now, let us first write this. Let me hope you write it now. You first note down this as we are aiming at doing the second example. Okay. We are aiming at doing the second example. Now, in this topic, you need to be having the knowledge of quadratics, yeah? Like the knowledge of quadratics, you need to be having it. Also, when we look at the factorization bit of it, you need to know how to factorize. You need to know how to deal with the difference of two squares. Whenever you see two numbers with a minus sign between them and their squares, you know that is the difference of two squares, addition, subtraction. It doesn't matter, you can start with x minus y, x plus y, but you're supposed to have these two brackets for that case. Okay, now I'm going to proceed. Tell me whether you people have finished writing. I think we are done. Now let us proceed to example 2. Allow me to clean this chalkboard and we proceed to example 2 or part B. That has been part A. Now we are proceeding to part B. We are also going to simplify this. What are you going to simplify? We are going to simplify, it is x squared plus x over x squared plus x over x squared plus 4x plus 3 plus 3. That is the fraction that we're going to deal with. Now when you look at this downer expression, this one here, it is a quadratic expression. Now, if it is a quadratic expression, how best did you deal with it? How best you deal with it? How best you deal with the quadratic expression? Now, this quadratic expression, as you hear the word quadratic, you know we are supposed to use factorization so that we have two brackets in this. Okay? We are going to use factorization so that we get two brackets. And remember factorization. If you have, remember the quadratic is always a squared plus bx plus c. We say you get two numbers with a sum of b and a product of a b. The multiplication of this and this. These two numbers must give you a sum of the number that is here and a product of these two. I know that we all looked at quadratics in our respective streams. Now, when you look at this quadratic, put it in this format. Now, a in this place is 1. It is 1a squared plus what is here? There is a 4x. And what is c? C is a 3 in this case. So you must look for a number with a sum of 4 and a product of 1 times 3, which is 3. So we are going to get two numbers with a sum of 4 and a product of 3. What are those numbers? You can look at those two numbers, like when you add them, you get 4, but when you multiply them, you get 3. What are those two numbers? You can look for them in the factors of 3. So 1, 2, 1, and 3. 3 has two factors because it is a prime number. So the two numbers are 1 and 3. I think you can able to see that if I add 1 plus 3, the answer will be 4. But if I multiply 1 times 3, the answer will be 3. So the two numbers with a sum of, when you add them, you get 4. But when you multiply them, you get 1 times 3, which is 3. 1 times 3, what is the answer? The answer is 3. So the two numbers, when you add them, some people may get confused here. Let me repeat this. When you add them, you get the number that is here. But when you multiply them, you get you look at the number that is here. There is 1, and here 3. When you multiply this to the number that you get, is the number that you must get again when you multiply the two numbers that you've got. So realize that the two numbers are 1 and 3. So here we are. So I'm going to say that this is equal to, I change this, and I say that this is, when you look at these two, x is common. I'm going to factorize out x, and I will remain with x plus 1 over, then you look at this, I'm going to change this to 4, and I put there two numbers with the sum of 4 and the product of 3. So it is x squared plus the numbers are 3. We have 3x plus x. So that when I add 3x plus x, I go back to 4x. So instead of having 4x, I'll put there the other two numbers that we've been talking about. The two numbers are 1 and 3. But since this one is containing x, I must also add 1x. I must also add x on the 1, and I add x on the 3. But if I write 1x, it really doesn't bring it out very well. As a mathematician, you can know that each unknown, in front of it, there is a number that is 1 if it is only given as 1. Here there is a coefficient of 1. So here there is also a coefficient of 1, even if I give it as x. That's why here I'm writing x alone. So it is 3x plus x, which will give me 4, then plus 3, eventually. Then I proceed. This is coming from this. And how have we come up with it? We are getting two numbers with a sum of the number that is here, a sum of 4 and a product of 1 times 3. So those are the two numbers. We proceed. Now, when I proceed here, I'm going to have x into x plus 1. Here, I'm going to factorize these two. You see these two? I'm going to factorize them, and I also factorize these two. And if I'm factorizing, they are going to become, here I will factorize out x, and I remain with x plus, because x is common on these two, I remain with x plus 3. And what is common here? It is 1. There is no number that is common here. So meaning I will factorize out 1. It is 1 that is common here. Factorize out 1 and remain with x plus 3. If I remove 1, when I multiply 1 with this, I go back to the original figure. Then this is going to be x into x plus 1 over, you look at this, this is a single bracket, and this one you can also take one bracket according to the quadratics that we looked at, right? So this is going to be x plus 1, and eventually we take one bracket of this, and this will be x plus 3. You can simply see that. Now, after having this, then eventually I'm going to look at the common brackets, and I cancel them. When you look at this, what are the common brackets? The common brackets are this and this. Can see them. Then eventually I remain with x over x plus 3 as my final answer. I told you cannot cancel this and this when there is an addition sign here, or when there is an addition sign up. They cannot cancel. So this is my solution for that case. But if you lack the knowledge of factorization here, if you see that there are 3 terms, you must look for a way of making them 4, so that you can easily, because in 3 terms you cannot get a bracket, 2 brackets out of it, but instead you cannot easily factorize this if they are 3, but you could find a way of making them 4 using the factorization. Get 2 numbers with the sum of this one here and the product of these 2. That is it for part B. Now let me allow you to write down what you've seen on part B. That is the solution for part B. Yes. Okay, now let me proceed. If you've finished, allow me to proceed. Remember, we are doing all of this, but the exercise, those of you who don't have, we may not get time to put on board the exercise, but you're going to get the exercise, because at the end of each lesson, you're supposed to do an exercise or an activity so that you determine yourself whether you've really gotten the concept or you're still lacking something out of it. And if you're lacking something, I've given you my WhatsApp number. Please go get down to the inbox and write to me. Tell me any difficulty that you have, or you can get into the group. The group is called Rising Mathematicians. If they add you in that group, please don't exit. Just know that that is the group that you're going to be using for various reasons. And those of you who have a tendency of using our group for other things, please, I request that you stop it today. So here we are. Now we are dealing with this. You can see that the main activity that you need to know, the knowledge that you need to have here is how to break this into two, or to make it two. And you're making it not simply because of this, but you consider two reasons. One, the sum of this and the product of the number here. When you multiply this and this, what you get should be the product of the other two, even when you multiply them, the numbers that you're getting. Now allow me to proceed to part C. I think we are fit to go to part C. What is part C telling us? Part C is telling us to factorize completely again. We are factorizing x squared minus y squared over, remember we are looking at algebraic fractions, over x squared, over x squared minus 6xy, and then plus 5y squared. You can go to the attachment. These numbers that we are doing are there. Okay, so that is the question that we're going to deal with. Now someone may tell me that the other one was the x squared plus 3x plus, was it plus 3 plus 4x here, I think, yeah? Now these ones, they had only one unknown, which is x, but these ones have x, y, x. Don't put more emphasis on these, but to put the emphasis on these numbers that start the equations. Don't put your emphasis on these. However much they are x, y, you will also add in x, y where necessary. Okay? But the emphasis should be put on these first letters and the fact that there are 3 terms. 1, 2, 3. There are 3 terms. You can see them. If there are 3 now, you look for a way of making them 4. How are you going to make them 4? You look for 2 numbers with a sum of 1 times 5. With a sum of negative 6. It is ax squared plus bx plus c is 0. Or it is that this is the expression. Let me remove the equation bit of it. Now this is x squared. It is representing this one. There is a 1 here, right? As they have not added it, but you know that there is a 1. It is representing a plus. Now this one is negative 6 xy. Now this one is this, but there is a negative 6 which is representing a b, right, in this equation. And then plus c, which c is 5y squared. Now this is the c, the whole of it, but we are only considering c as 5. We are only concentrating on 5 as the number represents c. Now we are looking for 2 numbers. You're going to look for 2 numbers with a sum of negative 6 and a product of 1 times 5. What do we have? We have 5. 2 numbers with a sum of negative 6 and a product of 5. 2 numbers with a sum of negative 6 and a product of 5. How are you going to come up with those numbers? When you multiply them, you get 5. But when you add them, you get negative 6. But when you multiply them, you get 5. What are those 2 numbers? Those 2 numbers will eventually be, you look for them in the factors of what? Those 2 numbers are, you look for them in the factors of 5. It is 1 and 5. Remember, 5 is a prime number. So those 2 numbers are negative 1 and negative 6. Negative 5, rather. Because if you add negative 1 plus negative 5, the answer is negative 6. But when you get negative 1 times negative 5, the answer is positive 5. So the two numbers are those ones. Those of you who have calculators, I also showed you how to use calculators to come up with those two factors. So now we know how to come up with those two factors. So I will say this is equaling to, we said that this one is yielding the difference of two squares. Whenever you see two squared numbers, when in between them there is a subtraction sign, you know that it is the difference of two squares. So it will be x plus y, x minus y. Whenever you see something of this kind, even if it is a squared minus b squared, it is a plus b, a minus b, like that. So this is x plus y, x minus y. Now you come on this. Two numbers, we've decided that the numbers are negative 5 and negative 1. So instead of having this, I'm going to have negative 5 and negative 1. So it's going to become x squared minus 5xy minus xy. These are the two numbers that when I add these ones, I go back to negative 6. There is a negative 1 here, but I'm not writing 1. There is a negative 1 and there is a negative 5. So it is negative 5xy minus xy plus 5y squared. That's what we have for that. I repeat this. This is, remember this one, I told you look for a way of making these ones 4. There are 3 terms. And how am I going to do it? Get two numbers with a sum of negative 6 and the product of this times this, it is 5. Right? So the two numbers are, when you look at it, you will say the two numbers are negative 1 and negative 5. So we are substituting them in this place where this one is. Negative 5, but they take these coefficients, they take these unknowns which are there. It is negative 5xy, then minus xy, minus 1xy, which is minus xy, probably. Then after getting this, you continue, and you continue to come up with we are going to factorize these ones further. You can see. So I'm going to have x plus y into x minus y, and down here we said we factorize two terms. This one you're factorizing it with this, and this one with that. So when you're looking at these two terms here, what is common? X is common in these two. X is here and it is there. So I'm going to factorize out x, and it is x, 1x. You take the x with you take the one with the smaller degree. This one is on degree 2 and this one is on degree 1. Now if I say that x squared is the one that is common, then this one is not x squared. But if I take x can also eventually go with this. You take the least factor. So the least factor in this place is x. So if I take out x, here I'm remaining with x. So I remember x times x, I go back to x squared. It is x minus 5y. Right? X minus 5y. And then here, I look at what is common. Close this bracket. Here, what is common? It is negative y. I can take this negative here, and I factorize out y. Y is common here. So here, I remain with it. Because these brackets must be the same, yeah? These brackets must be the same. Here, when I remove the negative, I'll remain with x minus. Why am I bringing in a minus? Because I want to, when I multiply this and this, I go back to the positive. Minus, this is 5y. And I want this bracket to be like this. Because I factorize out 1y, now I'm remaining with 1y here also. So that negative y times this, I go back to negative xy. And negative y times negative 5y, I go back to plus 5y squared. I'm going to move this at a very low pace because I don't want to leave anyone behind. Please, if you're left behind, don't hesitate to tell me or to write to me and tell me where you're lost from. I said the first one, look at these two. I think this one was simpler, but this one, there is a negative sign here. Now I take the negative sign this, and I bring the number that is common, which is y. Well, after taking this negative sign, here I'm going to remain with only x, because I'll factorize out y. But here I will bring a sign. I'm not bringing the positive sign. Why? Because if I put here plus, yeah, just in case I put here plus, see, just in case I put here positive sign. See, if you multiply this negative times positive, the answer here must be negative, which is not the case. The answer here is positive. So I'll put a sign so that when I multiply them, I go back to what is it in the other side. So the answer will be minus. Beg your pardon. The answer will be minus 5y. So that when I multiply this and this, negative y times this, I go back to plus y squared. When I continue, I'm going to open the brackets and this will be x plus y, x minus y, giving me the two brackets. This is the bracket on its own. So it is x minus y, and this is also bracket, which is x minus 5y. I take only one bracket of this. You take only one bracket. You looked at that in the what? The factorization bit of it. Now you look at these two brackets. You have brackets which are common. You can all see that this bracket is common with this. We cancel them out. And after cancelling them out, then we will say that x plus y over, what are we meaning with here? X minus 5y is the answer. Now don't cancel this and this and this and this. No, they cannot cancel when there are signs in between them. I repeat that. So this is our final answer. But the final answer will come in if you only know how to deal with these ones down here. That's where the problem is. Now I think for this one, this is very simple. But even this, it is very okay if you do a lot of practice. I told you that mathematics is all about practicing. Don't sit there and you say that for me, I gave up on math. Don't just give up. It's too early for you to give up. I can assure you that the juice is worth it a squeeze. Mathematics is very simple. It is very interesting. If at all you do a number and you get it out very well, you feel very happy and you feel very nice. So that is it. That's what we are supposed to do. Now I request that you write down this, and you, as you're writing, please sit there, write while not looking at the board. You people, you get headache for nothing. You can, if you've been following, you can also give it a try without looking onto the screen. You can write it very well. I repeat, please get these questions that we are doing from the website. There is even a school website. These ones are there. From the school website, you go there and you write in Chibuli SS, then you go to the website where there are motion pictures which are moving like this. They keep on changing. Below it, there is a link. Touch into that link, it will automatically take you to the classes. Then in the classes, you look at senior 3 or form 3. Please don't look at senior 4. I know that most of you are aiming for senior 4, but go to senior 3. Okay? Then after looking at senior 3, there you will see the mathematics topics that you're going to be handling here and there. All the topics that are there. Some of them may have handled them, but you will see the topics which are there. And after that, go and click on the algebraic equations and fractions. That is what we are looking at this material moment. So that is it for that. Now I'm going to look at other two examples. Remember, each example that I'm looking at has a different technique in it, and that technique will always yield us to others. So I want by the time you start doing the exercises, when you have all the techniques. Okay? And if you have a friend who has missed this lesson, please remind them that they can always get these lessons from the video library. These lessons are always there. You can always go and check on the lesson. Then we'll be at the same footing. Now I think we are done with this. We are done writing this. I request that I continue. The other thing, please don't cancel this and this. I know that most of you want to cancel a lot. Don't cancel this and this. I repeat, this is a suicide. They cannot cancel when there is an additional sign in between them. Or this and this, if there is an additional sign before them, They cannot cancel. That is in algebra. Please don't cancel them. I know most of you want to cancel. Someone will reach here and will be like, X. That is wrong. Please don't do that. Okay? I know that you're a very good student. You now know that. Now let me continue. That is part C. Now I'm going to part D. Part D. We are going to do another example concerning part D. What is part D? It is A. Part D. Part D. Part D. It is A minus 2B over AB, then plus minus, I think it is minus 3A minus B over A squared, then minus 1 over B. This is part D. Okay, that is the question that we are looking at. Now, if you have such a question, what do you do? This is AB, this is A squared, this is B, A minus 2B, 3A minus B. Now, here your emphasis will only be on the denominator. Look at the denominator. Then on the denominator, it's like when you have, let me give you an example. You have 1 over 2 minus 2 over 3, then minus 5 over 4. Now, if you're dealing with such a fraction, your emphasis will just be on these denominators. And what will you be looking at the denominator? You'll be in need of finding the LCM of the denominators. Finding the LCM, which denominators are 2, 3, and 4. Now, you identify the LCM of this, which is 4. You can all see that the LCM of 3, 4, and 2 is 4. That is the LCM. So after identifying the LCM, what will you do? You will say 1 over 2 times the LCM minus 2 over 3 times the LCM, right? Yes. Then you continue. Minus 5 over 4 times the LCM, which LCM you just got as a result of. You can use the long ladder method to find the LCM if it is so hard for you, but even some other LCM are easily seen. By 2 once by 2, this is 6. By 2 once by 2, this is 4. By 4 once by 3, this is 4. By 4 once by 4, this is 3. So you multiply 1 times this, you get 6 minus 2 times this, it will be 8 minus 5 times 3, this will be 15. Then you deal with these ones. I think these ones are now easier. Can even press them on the calculator. That is it for that fraction. This fraction has no difference with this, because even this one has denominators and numerators. So what you're going to do is to first of all identify the LCM of these denominators. The LCM is equivalent to, or the LCM is, you look at this, which one is the biggest unknown, or the one that has the highest, can I call it factor? The biggest factor is this one, or the biggest degree. So it is this one, A, and there is also B. So the LCM is A squared B. This is the LCM of this. Someone tell me, why are you not using the LCM as AB? I'm not using AB simply because this one is squared. If I choose to use A, then I will be leaving this one out. LCM, you're looking at the common multiple. Okay? Lowest common multiple. The LCM of these two, this and this, it is this one. So the LCM is A squared B. Okay? Now, after identifying that as the LCM, I'm going to multiply the LCM on each term. I'm going to multiply the LCM on each term. So I will say, eventually, this is going to become A minus 2B over AB times Z. I'm multiplying this times Z. Or I can multiply the LCM I can multiply the LCM with only the numerator. But remember, the numerator, it is more than one number. That's why I'm introducing in a small bracket here. A minus 2b, put this here, ab, then times the LCM, which is a squared b. This is the LCM. Then minus, this is 3a minus b, close brackets, times a squared b over a squared. With there. Then minus 1 over b. Now here I don't need a bracket because it is one term. A squared b. Multiplying the LCM everywhere. So after multiplying the LCM everywhere, you can simply see numbers which are the same. And if they are the same, you will able to cancel them. B, I'm cancelling because there is, I'm cancelling simply because there is a multiplication sign in between. The whole of this, we take it as one term. So that's why I'm cancelling. Some people tell me, "Oh, showed us that we don't cancel if there is addition or subtraction. But if there is multiplication and this is a bracket, then there I can cancel." So B is cancelling with B. You can see that. And then this A, it cancels, and here I reduce the A to remain with the A. And remember, there have been two A's. Now I have only one A. Here I also cancel this A squared with the A squared. I remain with the B alone. Here I will cancel with B, the B rather with the B. And I remain with A squared alone. Now I continue. So if this is going to be A minus B to B. Now this multiplication, if you have 2 times 3, it is the same as 3 times 2. Because in all of them you're going to get 6. So even this, if I have A multiplying the whole of this, I can able start with A into A minus 2B. So it is multiplying the whole of this. Remember, the denominators have been cancelled out. My instance of multiplying the LCM was to remove the denominators. Okay? Now I don't have any denominator. Minus, because I cancelled all of them. This one, if B is going to come in front, minus B into 3A minus B. Don't know whether we are there. This B is coming here, but this sign is going to remain here. Then minus, then I'm multiplying this times this, minus 1 times A squared. Hope we are together. This times this, because these ones are cancelled out. When I open the bracket, this is going to be A squared minus 2AB when I open the bracket. Then this is minus 3AB, and then plus B squared. Why am I getting a plus? When you multiply a negative times a negative, it will give you a positive. Then minus, this is going to be A squared. Hope we are here. This is A squared. Okay? So after getting this, eventually, I'm going to come and say that this one and this one, when you look at them, this is a negative and this is a positive. These ones are going to cancel. Don't know whether you can see them. You quickly cancel them. Don't even waste time. This one and this one, they cancel out. Because this is the positive and this is the negative. You make your work simple. Then you're going to make with negative and negative. Negative 2 plus negative 3, you consider the coefficients if these ones are the same. It is negative 5AB plus B squared. Okay? Then eventually, to organize your equation, to make it look better, you can start with the positive and it becomes B squared minus 5AB. Then when you look at these ones, there is a number that is common. They told us to, excuse me, to simplify completely. So I'm going to factorize out B. And when I factorize out B, it will eventually be B minus 5A as my answer. So this is the solution for that value. I've simplified it. To the end, you cannot simplify that any further. So I was trying to simplify this. And when you look at this, B is common. When I factorize out B, I mean with B here and I mean with 5A here. This is a negative, so I can choose to start with a positive to reorganize my equation. It is positive B squared minus, this is negative. I cannot write plus B squared. No. B squared and plus B squared are the same. Time is not our best ally. I repeat. Here, my first task was to identify the LCM of these 3 denominators. Now the LCM, I look for the biggest, but this one is A squared and this is B. I couldn't say that the LCM is AB. It is A squared because it is the biggest one, and then this is the B. Okay? Then after, I multiply the LCM on each fraction. I multiply it here, multiply it on this, and I multiply it on this. This is what I was doing there. This one, the common terms cancel. Here it was A squared. It cancelled and remained with only A. Okay, I have 15 minutes left. Those of you who have questions, please, you can write them there, or you can write them on the WhatsApp chat. I will be getting the questions. Can I get some questions there? People are asking me so that I can able reply them. Then this one will cancel with this, and I remain with B alone here. Which B now has I've shifted. I told you that 2 times 3 and 3 times 2 are the same. That's why the whole of this bracket times B. I can shift and start with B again, but this sign I maintain it there. Even this A times this, I can shift and start with A times this. That's what I was looking at, basically. Okay. There are no questions here. Let me hope we are at the same pace. Oh, we are at, because if people are not asking questions, it means we are okay. If people don't know where they can ask from, I told you can go to the comment section. You write there anything that you want to write. I hope you're not writing funny things. Write there comments or write there things that you would want to know. But you can write them there if you're watching live. Those of you who watch after the live session, sorry, you won't be replied because you'll be watching the video that is already in the library. Okay. Now, I request that you write this, and then I proceed to the last example. Before I also give you some questions that you're going to try out. I'm doing the last example, which is example E. I think D. Has been D. Now I'm going to go up to the last example. When you have very many denominators, you first bring in the LCM bit of it, and then you come up with the solution, which is here. Okay. Excuse me. Okay. Now the last example, which is example E. They're telling us to simplify. What are we simplifying? 1 over x plus y over x squared minus xy. When you look at that example, that's what we are going to simplify. 1 over x plus y over x squared minus xy. When you look at this and you want to simplify it very well, first of all, when you look at the denominator, there is something that you can really do what? There is something that you can really factorize before you go into any other thing. So it will be 1 over x plus y over x into x. Because here I have 2 x's. When I remove 1, it remains with x minus y. Simply because I've removed the 1x here. It is now outside the bracket. Now, after that, you can see that in this I can look for the LCM of this and the whole of this. You can ably see that the LCM is this one. This is the LCM. Because it is common. This is here and this is here. The LCM can be the... Because this one, x is a factor of this and it is also a factor here. So the LCM is x into x minus y. It is the LCM. So I can multiply the LCM everywhere on each term. So it is going to become 1 over x times x into x minus y. then plus y over x minus x into x minus y times x into x minus y. You see that? Now, here, this is going to cancel with this, and the whole of this is going to cancel with the whole of this because they are uniform. They cancel out. So the whole of this is cancelled, and this x is only cancelled with this x. So here, what are we going to remain with? Here, you're going to remain with this is 1 into, you remain with this bracket x minus y, plus, here there is y alone, y times here remain with 1. Because if they cancel, remain with 1. Y times 1. So this is x minus y plus y. The y's will go, and finally your answer will be x alone. Can you see that x minus x? This one is also cancel, negative, positive, you can cancel them, and the answer is now x. You see how you've simplified it, but simplifying it means whenever you see something that is factorizable, you first factorize that. Now here you first have to factorize x, and when you see this one, there are two factors which are here. This one is here and here, and this one is also there. So this is the LCM. Then you multiply it here and here. This is what I was doing here. Now when I multiply it here, there are only x's that are going to cancel. Why are they cancelling? Because there is a multiplication sign in between them. And then I cancel this with the whole of this. Then eventually I will come up with my answer as x. Now, after writing this, I don't know the minutes that I'm remaining with. But I have 9 minutes to go. Now I'm going to drop a simple exercise that you try out before we meet next time, inshallah. And I request that you submit or you send me the solutions very fast. I'm going to write some exercise here. I'm going to give you 2 questions from here, and then I'll go and write other questions, and you get them from the platform, the WhatsApp platform that we have. You get other questions, but here I'm going to give you 2 of them. Okay. So let me write that exercise here that you people are going to try out. EER. Simplify the following. Complete the at A. Excuse me. 2 into x minus y over 5 plus 3 into x plus 2y over 2. Talked about LCM when you're dealing with fractions. You multiply, get the common LCM of the denominators, and then you multiply it everywhere. Part B, you have x plus 1. Excuse me. It's x plus 1 over 4 into x minus 2 plus 1 into x minus 2 squared. X minus 2 squared. Now you've been positioned to identify which one is the LCM of those denominators. Those are the 2 questions that I'm going to leave you with, and I will bring in more questions, inshallah, on WhatsApp. I request that you people do those questions that I have left you with, and you try them out and you send me the solutions immediately. Then, secondly, we are going to be using that WhatsApp platform so much. So please don't hesitate and don't press the leaving button. Don't leave, because most of you are leaving. I don't know where you're going to be getting the information from. I normally use it for information clarifications and so on. So I let me take this opportunity to wish you a blessed day, a blessed week, and I pray that you stay free from COVID-19. Assalamu alaikum wa rahmatullahi wa barakatuh.